Okay, so again, function analysis, what I like to call it is function analysis, but what you're doing is you're relating f, its derivative, and its second derivative. And also you're looking at what's called curve sketching. So sketching curves, looking at a lot of graphs. Okay, so with function analysis, there's this really some nice, succinct summary charts that I'm kind of going to show you, and some things that will be really helpful tools for you when you are answering these types of questions. So we're really not learning anything particularly new today. It's just in how the questions are asked are going to be a little bit new, and the connections that you're going to make may be a little bit new. Okay, so function analysis. So let's think about first, if I have a function f. Okay, if you look at a graph of f, in algebra and in pre-calculus, we were concerned with finding the zeros of a function, right? We factored, we found the zeros, and we kind of made some analysis of function behavior, and you can kind of get the general graph, right? Okay, so what you know about f, and you might want to wait to write this all down until, let me put the whole thing together, and then you might want to write it down, okay? So f in algebra, you can tell whether it's positive or negative. That takes algebra, right? So when I say positive or negative, that means graphically above the x-axis or below the x-axis, okay? Graphically, that's what you're looking at. Now, what we're starting to see in calculus is that when is the function, I'm going to do an up arrow for, what do you think that represents? Increasing, or we're interested when the function is decreasing. So calculus, and what informs that? The derivative. So what I'm going to do on this next row is taking the derivative function. When do you know a function is increasing? When the derivative is positive. And when the function is decreasing, the derivative is negative. Now, so notice I put that right underneath the increasing and the decreasing arrow for f, right?
Oh, so then it's going to be increasing for that.
Correct. Yeah. So then what's the next thing that we learned in f? We talked about increasing and decreasing. What does the second derivative tell us about f? Okay, inflection, but concavity, right? Where I change concavity would be a point of inflection. So you've got concave up and you've got concave down. So I'm going to make another row. So if I make f prime, double prime, then underneath the concave up, concave down, you've got when the second derivative is positive and negative. And exactly what Zaid was saying, when you see that little white space there for f prime, what's going to go there? Yeah, so when f prime is increasing, f double prime is positive. And when f prime is decreasing, f double prime is negative. Okay? All right, so this is a really handy chart. Like you knew all that information, right? We've seen that before, but it's a really nice summary chart. And even when I'm answering some of the questions that we're doing today, I'll quickly draw this chart out because it's like kind of like a key, like a legend to help us as we answer some of these questions. You'll see its handiness as we work through some questions. The point of inflection is where a graph changes concavity. So it would be between here and here, right? If I change concavity from here to here, right, that would be a point of inflection. So that is what we've learned before. That's when the second derivative does what? Not necessarily the second derivative 0. It must change sign, right? Just equaling 0 does not mean I have a point of inflection. You must change sign. Now, what if the information that I gave you was the information about f prime, and you couldn't find the second derivative for whatever reason? How could you tell there's a point of inflection on f if the only information I gave you was f prime and you could not, for whatever reason, find the second derivative?
It's increasing or decreasing.
Yeah, where it's changing, where f prime is changing from, where f prime is changing from increasing to decreasing or decreasing to increasing. And what's really graphically happening there? Slope of 0 or undefined. Yeah, maxes and mins. So if you look at maxes and mins on f prime, that's where you have a point of inflection on f. Does that make sense? Okay, so this little chart helps with that, and we're going to see some questions that deal with that. So this is one chart that's really, really helpful, and I draw it a lot when I'm doing these type of questions. There's a second chart that really helps. So this is what I call my function analysis chart right there. There's a second chart that really helps because another thing that we're going to do is we're going to be looking at curve sketching. You might be asked to sketch a curve based on its derivative information, or you might ask to match a derivative with its function, okay? So there's a really helpful tool that helps out with that. So this is gonna be more like a chart, like a table, like a tic-tac-toe kind of thing. Okay, so let's do this. Let's make a box, a 2x2 box like this. So when you do a curve sketch, any curve that is a function, actually, it doesn't even have to be a function. Any curve can be made out of 4 pieces, okay? Those 4 pieces are looking at, let's do across the top, when f prime is greater than 0, or f prime can be less than 0, right? Those are my 2 options for f prime. It can be positive, it can be negative. Likewise, the second derivative, sorry, I don't know why it does that. The second derivative can be positive, or the second derivative can be negative. So what we're going to do is inside this little window is I'm going to take each of those combinations and we're going to draw a piece of the curve that matches that. Let's start in that first top right box, top left box. The top left box means the first derivative is positive and the second derivative is positive. That means we are increasing, and that means f is increasing and
Concave up.
concave up. Thank you, Raj. So I'm going to write that in there. F is increasing, and I'm going to say C up for concave up. Up like a cup. Draw what you think is a piece of a curve that looks like increasing and concave up. Do it lightly, and then I'll draw mine. You can check to see if it's right. Should look something like that. So now if f prime is less than 0, but we're still concave up, so in this next one, we have f is now decreasing and concave up. It's the other half of the cup, right? So decreasing and concave up, you would look like that. So now we're going to do the same thing. Let's flip it over, down like a frown. So you've got down like a frown, and you've got 2 sides to that concave down as well. You've got an increasing piece and you've got a decreasing piece, right? So now on this next one, we have f is increasing and now concave down. So that piece looks like this guy, increasing but concave down. And then of course, if f is decreasing and concave down, you get the other side of that frown. This is what I like to call the elbow macaroni of calculus. Because if you just take little elbow macaroni and you just move it around those different orientations, that's what you get, right? So you can make any curve out of these pieces. It's just how you piece them together. Does that make sense? Okay. So using these 2 charts, so using our function analysis chart up here, and then the little elbow macaronis, what we're going to do is we're just going to start now answering questions and seeing how they apply.